Hello and welcome to the part 24 of this video series. In this video, we will learn polymorphism. Polymorphism means many forms and it occurs when we have many classes that are related to each other by inheritance. I have opened up my Visual Studio and I have created four classes: employee, permanent employee, part-time employee, and temporary employee. All three child classes are inheriting the base class, that is employee. Now to understand the polymorphism, let's see an example. I will create an object of employee type. I will call it E1 equal to new employee. Okay. Now let's say I will create second object of employee type E2, and this time instead of assigning a employee object to it, I will assign a permanent employee object. So what I'm doing here, what I'm doing at line number 11, I am creating an object permanent employee and I am assigning it to a variable of type employee. Because permanent employee is inheriting employee type, we are able to do this. So this is possible because of polymorphism. Because permanent employee is also an employee, we can say employee E2 equal to new permanent employee. Let's create two more objects. See, we are still not getting any error. And if I try to build this application, we can see build is succeeded. And now let's understand how the methods will behave when we are having the polymorphism applied. Let's create method here, public. Okay, so I have added a method print full name that is printing first name and last name. Okay, I have initialized my variables with first name and last name. Now what I can do, I can invoke my print full name method on all my objects. E1 dot print full name. Okay, so I'm invoking print full name method using all these objects E1, E2, E3, and E4. If I run this program, as expected, we are getting full first name, last name, fn, and ln for all four objects. Now let's pause. What we want to do for all the employees, we want to mention their type also. Fn, ln. Then we want to print their type also, like if they are permanent employee. So what I want to do, I want to print like this. I want to print first name, last name, and then the dash, and then the type of the employee, permanent employee, temporary employee, or part-time employee. So let's see how we can achieve it. To achieve it, we can create methods in our class. So I can add the permanent employee here. Okay, so now I have added the print full name method in our all four classes, and each class has their own implementation. Now if I try to run the program again, you will notice there is no change. We are still getting fn ln. This is because we have created the objects with the reference of employee type. So every time we are invoking the E1 dot print full name or E2 dot print full name, it will always go to parent class and invoke this method. So if we want to invoke the methods from the child class, what we can do, we can create our parent class method as virtual. So if I use the virtual keyword here, this will make our method as virtual, and now child classes can override this method. Let me show you how. And now let me say, let's type override keyword and put a space after it. If you notice here, Visual Studio is giving us the options which methods we can override, and you can see we are having this option print full name that is available to override. If I double click, it will create the method for us, and we can provide our implementation that is specific to the child class within it. So I will copy this line and paste it here. Similarly, I can do the same thing for my other child classes also. Now child classes are overriding the method definition present in our parent class. Now if I try to run the program, you will notice we are getting the output as expected. For employee class object, we are getting first name, last name, and for the other objects, we are getting the respective, we are invoking the respective print full name method, and we are also printing the type of employee, that is permanent, part-time, and temporary. So this is how we can create virtual methods in parent class and override those virtual methods in our child classes. And the benefit of using the virtual method is that suppose we don't want to give any implementation to our temporary employee class, and we just want to use the implementation provided by the parent class. What we can do, we can simply remove this method from here. And if you notice, we are still not getting any error, because when we are invoking print full name method for our temporary class object, it will invoke the method from employee class. If I hover over here, you can see it is pointing to employee class dot print full name method. If I run the program, you will see for the permanent employee and part-time employee, they are having their own implementation, but because we don't have any implementation in our temporary class, that time it will go ahead and print the method that is available in the parent class. Let's go back to slides now. So we have seen polymorphism is one of the primary pillar of the object-oriented programming. In the previous videos, we have seen inheritance. That is also one of the important pillars in OPS concept. And this is the second pillar that is called as polymorphism. Polymorphism allows you to invoke derived class method through a base class reference during runtime. You have seen we have used the employee class reference, and we were storing object of different child classes in that, and we were able to invoke methods from the derived or parent class. In the base class, the method is declared virtual, and in the derived class we override the same method. We have seen that we have declared the method print full name as virtual in our parent class, and child classes were able to override that method. The virtual keyword indicates the method can be overridden in derived class. If you don't use the virtual keyword, in that case that will hide the method. That's it for this video, guys. In the next video we will try to learn the difference between method overriding and method hiding.